According to researchers, 1 in every 3 women has been a victim of domestic abuse. Suppose we randomly sample 15 women and find that 4 have been abused. Our first question is asking what's the probability of observing 4 or more abused women. Again, it's important to see that we're at 4 or more abused women, not exactly 4. For this, because our proportion is 1/3, we can't use our chart in the back of the book, so I'm going to look at this as the probability of observing x that is greater than or equal to 4, which I know is the same as 1 minus the probability of x is less than or equal to 3. Now I'm going to use my binomial random variable theorem to find the probability at 3, 2, 1, and 0. So that's going to look something like this. 15 choose 3. Our probability is 1/3 raised to the 3rd power times 2/3 raised to the 12th power. Some quick calculations, I find that this is 0.130. I'm going to do this same thing for 15 choose 2, 1/3 raised to the 2nd, 2/3 raised to the 13th. Find that this is 0.060. 15 choose 1 times the rest. These dot dot dots mean the rest of this binomial random variable theorem. I have 15 choose 1 is 0.017. And 15 choose 0. Now again, you can choose 0. Dot dot dot, that rest of the theorem is 0.002. Adding up 0.130, 0.060, 0.017, and 0.002. I have 0.209, so I have 1 minus 0.209 would be the probability of 4 or more. Again, I took each of these probabilities, 3, 2, 1, and 0, added them up. Now 1 minus all those probabilities gives me about 0.791. Now for this second case, some experts believe that the proportion of women domestically abused is closer to a probability of 0.10. They want us to do the same experiment, observing 4 or more, if we have a sample of 15 at 0.10. Well, for this one, we can use our chart in the appendix. Knowing that our n is going to be 15, again, I'm going to do 1 minus the probability of being less than or equal to 3, since I am at the probability of x is greater than or equal to 4. So I'm going to look up n is 15, x is 3, and my probability is 0.10. This gives me an answer of 0.944, so 1 minus 0.944 is 0.056, and that is my answer.